Greetings and welcome, friends. We've been talking about like conjectures and laws and properties of logic and things like that, and we're gonna go over the homework right now. It says describe the pattern. So basically, it looks like for each consecutive group, you add a cube on all four sides, I guess, if I can use that term. Right, and in terms of like kind of putting language to this, I guess, you know, having descriptions and definitions for the things I mean. But yeah, by sides, I'm referring to kind of the horizontally out-facing faces of this cube. Of course, we are perhaps perceiving this as being a three-dimensional object, which I think is the easiest way to model it. And then as well as the top face. Right, so that's kind of my descriptor here. Let's see if I can cheat. I'm gonna steal their drawing here, and then I'll add to it. And let's see if that works. I'll do it down here. Why not? So okay. So yeah. So I would add a cube here, right? And here. And over here, right? So these are kind of like the four outermost faces. Also, this back one would get a cube, right? And I guess I'm drawing kind of transparent cubes on some of these. I'll just stick with that, even though that's not what was drawn. And then as well as this top cube. How wonderful is that? Wow. Yeah. So there you go. Wonderful little sketch for you. I'm proud of my drawing. Let's take a look at another one. I've got quite a few of these. It says make and test a conjecture, so like a hypothesis about the given quantity. So the quotient, meaning I'm dividing two things, of a number and its reciprocal. So let's try let that number be 2, and the reciprocal of 2 is a half. Does anyone know what 2 divided by a half is? Well, 2 divided by 2 would be 1. But how many, this would be like, yeah, it'd be 4. It'd be like, how many ways does 50 cents divide into $2? You'd have 4 50-cent pieces if those existed in frequency needed. So yeah, so this would actually equal 4. If you do like 3 divided by a third, and I'm trying not to like use my soon-to-be conjecture in developing these answers, but a third fits into 1 3 times, so it fits into 3 times as many, so that's going to be 9. So yeah, I don't know if you guys can kind of make a conjecture. It is going to equal the square of the number, right? It is the square of the number. It is of the number is my conjecture. Did anyone have a different thought or a different way of saying it? If I have x over 1 over x, this is the same as multiplying by the reciprocal. So that's the same as taking x over 1 multiplied by x, and that is equal to x squared. So here it is kind of shown in a little bit more generic form. But I don't know if they wanted me to like pretend not to know the multiply by reciprocal thing. So I don't know. But that's my conjecture. Let's see. Oh, let's find a counterexample. So they are claiming that the product of 2 positive numbers is always greater than either number. So they're saying A times B is going to be greater than A, and A times B is greater than B. Yeah. So what do you guys think? True, or could you come up with a counterexample? 1 times 3. Oh, okay. Oh, wow. I was so slow to. You're right. Yeah, it's not greater than 3. Okay. Did someone find another counterexample? Yeah, if we do basically any value between this is equal to a fourth. Any value between 0 and 1. Right, so that is not true. So there's a counterexample. Any value of x, if that was one of the numbers that is greater than 0 and less than or equal to 1. I didn't even consider the fact that 1 worked. So yeah, there you go. So now this person could either modify their conjecture or just forever leave it and forget that they ever made it. I don't know. Let's see, the law of detachment. Here we go. So the law of detachment was kind of literally just the application of an if-then statement. It is knowing that an if-then statement is true, and then knowing that the hypothesis of that if-then statement is true allows you to conclude the if-then statement. So let's see. It says, if a quadrilateral is a square, so here's the hypothesis of an if-then statement. So if a quadrilateral is a square, quadrilateral is a four-sided figure, then it has 4 right angles. So that's my Q. All right. Then they gave me a fact. They said quadrilateral QRST has 4 right angles. Is that P or Q? That's Q. And notice we have no claim on whether or not Q implies P. We don't know, right? We don't know this. So this is not an example of the law of detachment. I can't apply the logic. You might know things about quadrilaterals and stuff like that, but if the only thing I knew were these 2 statements, statement 1 and statement 2 as being true, there is not a conclusion I can make. The law of detachment would only have worked if I knew that the hypothesis was true. Then I could have concluded Q as being true. All right, so yeah, so that's a no-go. What do I actually have to say? Did I answer the question? So I can't determine. So no es posible. No possible, not possible. All right. And yeah, like it's subtle, right? That's why I like kind of my color coding thing, so I can keep track of that. All right, let's see if the law of syllogism, what I refer to as the transitive property of logic, applies. Let's see, let's do some, color coding. If a figure is a rhombus, all right, so P, so P implies something, then the figure is a parallelogram, so there's Q. And then I have another statement that's true. If the figure is a parallelogram, or a figure is a parallelogram, so there's Q again, then the figure has 2 pairs of opposite sides being parallel. So that would be like R. All right. So I have P implies Q and Q implies R as being 2 statements that are true. What can I conclude? Yeah, P implies R, right? I can skip the middleman, basically. I can just say, hey, well, let's just forget this whole Q business. If a figure is a rhombus, then it has 2 pairs of opposite sides parallel. Now, notice what I'm concluding is an if-then statement. I am not concluding that whatever figure I have has 2 pairs of opposite sides parallel, because I don't even know that the figure I have is a rhombus or a parallelogram. All I knew was true was 2 conditional statements, and the conclusion is a 3rd conditional statement. The conclusion was not R is true. I don't know if P or Q or R are true. My only conclusion is a conditional statement. So I could write, if a figure is a rhombus, I guess I'll write it out for us. Writing out, people. Figure man is a rhombus. Then, do you guys, by the way, do you think this is true? Do you think these are true statements? 2 pairs of... Yeah, it is true. It is true. Parallel. Yeah, a rhombus is a type of parallelogram, and parallelograms, by definition, have two pairs of opposite sides that are parallel. So parallelogram is a quadrilateral in which doot and doot and doot is true. And then there's a whole bunch of other things that are true. So this is kind of like def of parallelo is what I usually say. Parallelo. And then, yeah, we'll discover all sorts of other properties later and prove them. But that's for a much, much later chapter. Let's see. State the law of logic that is illustrated. So, let's see. So if angle 1 and angle 2 are vertical angles, so there's a P, then angle 1 is congruent to angle 2. So this is a Q. Is that true, by the way? Yeah, well, it might take some justification. Let's see. Then they said if angle 1 is congruent to angle 2, so there's Q again, then measure of angle 1 is congruent to angle 2. So that's like an R. So Q implies R. This second statement is what I would refer to as def of Kong, definition of congruent angles. All right. If the angles are congruent, then their measures are equal, and that is also true vice versa. If the measures are equal, then the angles are congruent. And then, let's see, they are then saying, it looks like if angles 1 and 2 are vertical angles, so there's P, then their measures are equal, which is R. And, yeah, that's which law of logic? Yeah, the law of syllogism. All right. Right. So a conditional statement plus another conditional statement resulting in a conditional statement not making any claims about whether or not, I mean, my angles are even vertical angles. I don't know. This is just completely random sort of stuff. And what's important is that the conclusion of one could be linked up to the hypothesis of another, right? I need to be able to chain those together in that way. Let's see, did I pick one more? Yeah, it looks like, oh yes, here we go. So basically this first statement as a conditional statement is if man, then mortal, right? So that's an if-then statement. And statement 2, Mozart is a man. I don't think they're going for if you are Mozart, then you are a man. I think they're saying like that, or are they? No, I think they're just applying. They're saying that the P is true, basically. Yeah, I think they're saying that that's true. So man, therefore, mortal. I think that's what they're going for. So man, mortal, right? So this looks like law of detachment, right? Because I had P implies Q. Oh, blast. Man, I'm not even like reading the instructions, and I knew this. This, by the way, is deductive reasoning. I wasn't using a pattern unless you were describing the pattern of all of humanity marching towards death. That's a pretty despairing pattern that I've noticed. I don't know. It's almost like my life is coming to an end, and these moments are passing away before me. But at least I get to participate in something meaningful and mathematical, and it's going to last for generations past my existence. I'm fine being the link between the transitive property of A equals B and B equals C. I want to see generation C. You guys know math. Wow, I don't know. I'm just going to stop rambling. Thanks for everything. Have a great day. Boy.